you can make mass timber panels, these sort of laminated materials in a factory, to the exact specifications of an architect or designer. And then you carry them, transport them to the building site, and then assemble them to the prefabricated, pre-designed structures. Not, frankly, dissimilar to Lego in some cases.
You have to make sure that not only you have enough housing, but you have great neighborhoods. That it's such an important part of economic development. Whether we're talking, EV battery manufacturing in St. Thomas or the pea plant in Portage La Prairie, Manitoba.
Hi, and welcome to The Missing Middle. I'm Kara Stern.
And I'm Mike Moffat.
And today we're talking to Nicholas Renzetti, a research associate here at the Smart Prosperity Institute, about the skills that young people need as we transition to a more sustainable economy. And spoiler alert, working with mass timber is one of them.
But before we begin, don't forget to like, subscribe, and leave a comment. We'd love to hear from you.
We know that the transition to net zero is going to change the kinds of jobs that Canadians do, and it's easy to focus on the jobs that won't exist 10 or 20 years from now, and especially if you're a young person maybe starting out in your career, it has to feel like so many options are just being taken off the table right now. But that thinking does miss all the great opportunities that the transition is creating. And one of those is in mass timber, which is one of the focus of your area, Nicholas, your work at SBI. And that has huge relevance in the housing construction sector. So first of all, what is mass timber?
Well, first of all, Karen, Mike, thank you so much for having me on The Missing Middle. It's a pleasure to be here. Mass timber is an engineered wood product. Generally, you glue several layers of compressed wood, which are then laminated together. This opportunity, both in making the mass timber products, but then in using more mass timber in construction, has been recently gaining more focus and investment in recent years, especially in British Columbia. Mass timber products can be used in a wide range of construction, from single-family houses to large-scale public buildings, and even 12 to 18-story condo buildings. It's also projected by the BC government to add over 4,000 new jobs to the provincial economy in the next decade.
What makes mass timber such a potentially attractive opportunity for our economy in Canada?
It's a good question. Well, Canada is already a world leader in forestry products, in lumber and timber and building materials, and we have workers already across the supply chain, from harvesting trees all the way through to builders and tradespeople who already have many of the skills needed to expand mass timber production and adoption successfully. We see mass timber production as an opportunity to build more housing, reduce greenhouse gas emissions from new construction, and create jobs manufacturing value-added wood products in British Columbia's forestry economy. There's also potential for mass timber to be a solution to some of the economic challenges that forestry communities in BC have seen with some closure of sawmills over the last several years.
There's a whole supply chain here, from forest to end product. But obviously, Kara and I are very interested in mass timber because housing is our kind of thing. So, at the sort of other far end of the supply chain. So, could you tell us more about the growth that you see in this mass timber market as it relates to the construction of housing?
Yeah, with regards to housing, there was a current estimate from Natural Resource Canada, which tracks the sort of things, which shows the progress of building or in progress mass timber buildings, that around 750 built. Now, that might seem like a small number, but a lot of these are what we'd think of as sort of like exhibits or pilot programs. They're proof of concepts that mass timber can be used in tall buildings or in sort of quick building applications. One really prominent example is the University of British Columbia's Brock Commons Tall House, which was a project to build over 400 student resident spaces with mass timber materials in a short amount of time. However, outside of these proof of concept buildings, there is a real potential for mass timber to be used in housing construction, even though it's still not the most commonly used building material in most projects. Prefabricated mass timber panels can be used to assemble buildings potentially faster and cheaper than with alternative, more traditional materials, and can reduce the embedded carbon emissions associated with such construction.
Are there advantages for using mass timber over more traditional home building methods? Like, is it faster, cheaper? I know you mentioned that there's lower carbon associated with it, but what else is there?
Yeah, it's a great question. So, mass timber does have the potential to be all of the above. In terms of the production process, you can make mass timber panels, the sort of laminated materials in a factory, to the exact specifications of an architect or designer. And then you carry them, transport them to the building site, and then assemble them to the prefabricated, pre designed structures. Not frankly dissimilar to Lego in some cases. This process can, save a lot of time and therefore reduce cost, which is very important. The Transition Accelerator recently found that using mass timber construction could reduce building times by up to 20%, which is huge. As for lower carbon emissions, much of a building's lifetime carbon emissions are embedded in the materials, which traditionally have been steel and concrete, which, as you guys know, are two very carbon intensive building materials. Mass timber offers the potential to have lower embedded carbon than these materials, but this is an area where more research is needed on sort of life cycle analysis as well as the emissions associated with harvesting trees. One side amusing benefit of mass timber is that mass timber buildings actually are quite fire resistant. This is one of those things that might seem counterintuitive because they are, well, wood products, but extensive fire testing with them for safety reasons has shown they're quite fire resistant. There's even some Californian communities which are experimenting with mass timber as an adaptation in areas prone to wildlife. So there's some additional adaptation and security benefits there.
So are they as fire resistant as traditional home building methods?
I think part of that is relates to how they are constructed in the area that they're built in, but they're not more fire they're not less fire resistant than traditional resistant materials.
Yeah, I was particularly interested in that kind of Lego comment as somebody who grew up
Yeah.
absolutely loving Legos as a kid, and if you had told
You
me
don't
in the
still?
I still I'm just a little bit in denial about it. They're not my Legos. They belong to my kids. I
Right,
just
right.
happen to be helping them out. So
Yeah.
if you had told me back in the mid '80s when I was putting together my Lego spaceships and that I could turn that into a career, that would have been really exciting to me. And I know a large part of our audience is young people thinking about their future career and their parents thinking about the careers for their kids. Now, it sounds like there will be all kinds of opportunities across the mass timber supply chain. So, what skills, if I am that, not necessarily the 7-year-old playing with Lego, but if I'm the 17-year-old or 22-year-old or their parents, what skills should I be thinking about acquiring now to make that happen, to be able to get a good job in the mass timber industry?
Yeah, well, apart from playing with Legos, I think the thing important is that mass timber is still a forestry product. So there needs all of the skills necessary for logging, milling, grading, plus some additional skills in sort of biodiversity and the sustainability around the harvesting and transporting trees. Like you're sort of talking about, the manufacturing process for mass timber incorporates a lot of new, more novel digital technology, such as computer assisted design, building modeling, or using computer numerical control machines to produce the panels. It's less like, taking a singular I beam and then applying it in a lot of situations. It's making a panel specifically to fit the needs of a particular build site, and that requires new skills there. This sort of adoption of new technological processes is one of the things which makes mass timber exciting and opens up a lot of opportunities for sort of new people with different backgrounds and trainings to enter into the workforce, and especially of interest to individuals from equity serving backgrounds. Some of the occupations which we found through the research will be most in demand include woodworking operators, lumber graders, manufacturing managers, and production managers who have that sort of mass timber comfort and experience. And then, in addition to sort of the manufacturing process, there's a needed greater coordination understanding how to include mass timber materials in a particular construction site. This will involve designers, architects, engineers, construction managers, and tradespeople to gain familiarity with mass timber products and how best to use them. And the last thing that I'll say on this is that across all of our research, we found that some of the most useful skills for anyone in the green economy are soft skills. It's problem solving, it's communication, it's judgment and decision making. It's these things that allow you to work well on any particular opportunity and adapt to new situations. And those soft skills are some of the ones that we found most in demand across a wide variety of opportunities, but mass timber in particular.
A lot of those skills that you mentioned, those jobs that are relevant, those are things that are already being taught in post-secondary education because, like, those jobs already exist in some form. Are colleges and universities going to have to change what they're teaching or their way they're teaching in order to help this transition?
Well, the good news about that is that there are some existing institutions out there that do offer some courses related to mass timber, specifically the University of Northern British Columbia and University of British Columbia, as well as the BC Institute of Technology and the College of New Caledonia all offer a few courses around mass timber production, but often these are shorter micro-credential courses. However, what we need from training programs is a focus on upskilling and reskilling existing workers, as well as improving the accessibility and affordability of training programs for new workers. In terms of curriculum skills, having more courses available, both within BC and across the country around general wood skills, sort of the core competency for working with wood, either in production or in construction, can help to create more workers who are ready to get started in mass timber. Shorter programs aimed at those digital skills like computer design would also be benefit. The method for designing the panels themselves before you go into production. One of the reasons we focus in our research on retraining existing workers is that stakeholders who we talked to estimated that on average, an engineer would only need about 60 hours of additional training to work with mass timber products, which is, when you consider the amount of time it takes to train an engineer in the first place, that's quite impressive. Institutions, we think, should also look towards expanding the available workforce by providing scholarships for people from equity deserving communities and sort of expanding the potential range of people who can work there. Finally, one last thing that I'll say on this is that while universities have a lot of really essential training and educational opportunities, we see a lot of potential for sort of local colleges to lead the way. We've spoken to a lot of them over the course of the project, and they often have work integrated learning opportunities that let learners and students give an opportunity to really develop the skills in sort of a hands-on process working with local businesses.
Are there still other changes that need to be made across the board for universities, or that other ones, if anyone's listening, making policy for universities, planning anything that they need to actually change?
I think it comes down to access and availability, because while some programs do exist, they're not as widely adopted, or the sort of small scale micro credential programs, or they're only located in the communities. So, for example, something like the uh, College of New Caledonia offers some great programs, but they're obviously located in the communities where they're in. Some programs have started looking at providing online learning, which is very, it's much more accessible and helps. It's easier to adopt some of the more digital skill learning processes, but sometimes in some situations there's no sort of substitute for learning how to do it in sort of a hands-on process, especially when you're dealing with construction or trades.
Yeah, so like if I'm thinking about how do we scale up the number of mass timber buildings, I always tend to, on any project, and anybody who's read any of my work, I always think in terms of bottlenecks. And you can think of some, you actually have to have the mass timber to begin with, right? So we need to be producing it enough. And we just in the last few minutes talked about the skilled labor piece. You need to have the people who can actually use the material, design buildings with the material, and so on. Beyond that, do you see any other challenges or potential bottlenecks of builders actually adopting mass timber construction?
Yeah, adaptation is something that is, as you talked about, there are some bottlenecks there. Some of those specific challenges relating to, as you mentioned, bottlenecks are, the availability of the input to the production process. We've talked to people who said that there's a lack of access to sufficient wood fiber, which is sort of the base building material, because of the demand for wood products across the economy and internationally in a variety of areas. And that lack of access to sufficient wood fiber has sort of slowed down the growth of the sector. There's large demands are in traditional construction for sort of normal timber products and wood products and biofuels. Going to need to be a expand sort of that production capacity in sort of in a way that's sustainable to the sort of the local ecology. Another challenge is the lack of awareness and sort of comfort in using mass timber as a housing construction. Someone who's a designer or a construction manager, they might not be familiar with using mass timber in their sort of their build process. So there is the sort of stickiness towards traditional methods and materials. Finally, in some cases for adoption, this, as I'm sure is no surprise to your listeners, this is an issue of building codes, zoning, and regulation. Mass timber buildings often need slightly different building permits, as much as the construction is done off-site, and that requires a different set of approval process. Design guidelines and zoning rules must incorporate, the different needs of mass timber builders, such as they need to have different height requirements to accommodate thicker floors that are needed for a mass timber assembly. The St. Francis University's Renewable Cities Initiative has done really great work in highlighting how cities can do more to encourage mass timber construction through zoning and regulation.
What types of buildings are best suited for mass timber? Like, are you talking big apartment buildings or single family homes or those six pluxes missing middle kind of thing that we talk about?
Yeah, because of, how malleable mass timber construction is, the laminated panels can be prefabricated to fit the needs of almost any design process, which is one of the things that's so interesting about them. The 2021 International Building Code granted that mass timber can be used in residential and commercial buildings up to 18 stories. And the city of Vancouver has been one of the places leading the way on this. By earlier this year, they increased the height limit of mass timber buildings to that limit of 18 stories, up from previously just 12 stories. So in some cases, this is an area where municipal zoning regulations need to keep up with the technology. Mass timber can also fit well into those sort of smaller 6-story infill type buildings because of that decreased building cost and time through the sort of prefabricated sections. An architect who's sort of trained in the computer models could much more quickly create something that would fit into a particular location of the construction site, and then workers could just manufacture and assemble mass timber panels exactly to those specifications into the needing middle type housing.
Why do governments seem so hesitant to allow mass timber? If it's like, it seems like you're talking about all these benefits to it, but I know I've heard politicians say like, "Oh, well, that'd be a huge change. We don't know. We have to think about it." What is the barrier there?
I think a part of it is just sort of unfamiliar with the process. And within sort of Canada, a lot of the mass timber are sort of like, as I mentioned, sort of like proof of concept ones. So they're like, oh, well, here's a new, building in the university that incorporates mass timber, but people haven't really seen how it can actually interact, how useful it is in a variety of applications. Another component of that is, in North America at least, the production side of making mass timber is still developing. There are still, relatively few employers and businesses making it. So that, as you mentioned, Mike, that sort of bottleneck there creates that, if the materials are, less available and more expensive, it's harder for people to sort of see the transition over. And then it's also harder if you don't have people. If you don't have an architect who's familiar with it, who's taken a training course, if you don't have a building engineer who's able to overlook the process and improve it. So I think in some ways, some governments have been sort of moving faster on this than others. As I mentioned, the city of Vancouver has been moving very quickly ahead on this, as has the government of British Columbia has also been moving forward quite aggressively with regards to mass timber buildings. But that's also because they're so close to the production process. They're so close to the building process of mass timber there. So I think as we sort of start solving some of these production bottlenecks around supply of wood fiber and around skills available, I think that'll also lead to businesses, both municipal, provincial, and federal, seeing it more as an option and start making those shifts away. Because currently, a lot of them are making those shifts as they're being developers and as and construction people are looking to make those changes. I think we're going to start seeing people being more proactive about it.
Yeah, and you have to know that the Kara and I could talk about zoning and building code for all day, and I think we actually have some days here at SPI. But speaking of SPI, I know you and your team, you don't just do mass timber. That you are looking at a variety of sectors beyond housing, beyond mass timber, where decarbonization is going to create more job opportunities for young workers. So, can you run that through? Like, what are the other sectors that we should be looking at beyond mass timber and housing?
Yeah. So first of all, there's a variety of opportunities available across many decarbonizing industries in the country. Two in particular that we studied alongside mass timber are zero emissions vehicles and plant-based protein manufacturing. Zero emission vehicles are much more well known and represent the shift away from internal combustion vehicles to hybrid or battery powered cars. Think Tesla, think Volt, think these sort of production processes. This shift will require skilled workers across the supply chain, from skilled critical mineral mining to battery design to vehicle assembly to then construction of the associated charging infrastructure across the country. Plant based proteins is a more recent development, but it builds off Canada's position as a world leader in growing the crops needed for plant based proteins, such as peas, pulses, oilseeds, and canola. On farm and in food manufacturing, there's a critical need for young workers, especially with those with skills in machinery, digital technology, and automation. In both these opportunities, we have seen significant recent foreign and domestic investment in sort of growing Canada's production capacity, but they need workers necessary to ensure that growth. There are opportunities up and down the supply chain for existing workers to upskill and retrain, but without the workers available to undertake these opportunities, it's really a challenge. Within decarboning industries that were sort of these, and including others such as within clean power generation, there's a lot of overlap in sort of the skills and occupations needed. Occupations like electricians, welders, manufacturing supervisors have a lot of cross-sectoral demand in highly different areas. And as sort of mentioned, that sort of core problem solving, communication, decision making, and continuous learning skills are needed across many different decarbonizing opportunities.
Is there anything that we haven't covered that you think that people should know about this?
Well, apart from just mass timber as an opportunity, and people should look into it, I think it's that, within mass timber and within a lot of green growth opportunities, when we're talking about workers, it's not just to adopt a invest or build it and they will come approach. Investment alone can't really solve these problems. It takes a much more holistic approach that includes looking at health infrastructure, like housing with the missing middle, like transportation, childcare, healthcare, amenities, and settlement services to ensure sustainable growth. One specific example, which sort of comes to mind on this, is Portage la Prairie, Manitoba, which saw the investment of a $600 million pea processing plant into their community. This required substantive changes in the local community to their infrastructure to ensure that the construction workers and then the permanent employees of the plant would have sufficient housing and transportation. The city also had to undertake upgrades to the local water and sewage grid to ensure that the plant had sufficient utility connections to meet the demand. Ultimately, you're not really going to have a reliable workforce to build the housing of the future or assemble electric vehicles if the same workers don't really have anywhere to live or if the communities that they're located in can't support their families' needs.
Yeah, and that's such an important point, and I know I'm sure your team has seen that in St. Thomas, Ontario, with the battery plant and so on. So, I think this is a great place to end off. Sort of recognizing, as I call it, the housing theory of everything, where you have to make sure that not only you have enough housing, but you have great neighborhoods. That it's such an important part of economic development, whether we're talking, EV battery manufacturing in St. Thomas or the pea plant in Portage la Prairie, Manitoba is really, really important. So, Nicholas, I can't thank you enough for coming on today. You've really given us a lot to think about. So thanks so much for being here.
Well, thank you for having me, guys. It's been a pleasure and happy to talk about these issues.
Thanks so much for watching and listening, and thanks as always to our producer, Meredith Martin.
If you have any thoughts or questions about future-proofing your skills, please send us an email to missingmiddlepodcast@gmail.com.
And we'll see you next time.